Welcome and thank you for joining. Let's take a look at a homework question. This one is from the Nelson textbook on page 378, number 18. So let's read the question first. And when you read the question, read with purpose. So try to understand the information given and try to visualize what type of information is it, what does it represent. And another very important thing that I want to emphasize here is that, especially when we read geometry questions, but not just geometry, math questions in general, but any problem in life really, we have to read the information carefully without making any assumptions. So if the information is not specifically described, so if a piece of information or a characteristic of a quantity is not specifically given, then we cannot assume that it exists. So I'll explain it as I read the problem, what I meant. So vector A is a unit vector, means that vector A will have a magnitude of 1 unit. Vector B is any other non-zero vector, so we are specifically given the fact that B is different than 0, so it's not going to make terms disappear. So when we multiply anything by 0, terms will disappear. That's what they're trying to emphasize in here. And another thing, and a mistake that people make very often, is that because they see the word unit vector here and they think, oh, okay, so maybe this one is a unit vector as well. So again, try to separate one piece of information from the other, and if it is not specified, if it is not given, then it doesn't exist. We cannot assume it exists. So vector B will have a magnitude different than 0, and obviously it's not going to be a special vector or a unit vector. Now, some other vector C would be equal to B dot A multiplied by vector A. Now recall that B dot A is a scalar. So a scalar multiplied by a vector, so this is the special product, the dot product, whereas this one here is like the regular multiplication. So try to separate the idea of dot product with simple product or simple multiplication. So what we have in here is a scalar multiplying a vector, so that means that we have a vector quantity as indicated, which is equal to a number times a vector. And a fourth vector, vector D, would equal B minus C. Now we have to prove that D dot A equals 0. And again, before I start with the solution, read the problem more than once if necessary, twice, 3 times, it doesn't really matter. But try to stay focused as you read the problem and try to read with purpose. Now, first things first, I like to organize the information in a problem as given and required. So for this, I try to organize the information in a T-chart. So on the first row, I'm going to write the given information. So we are given that C equals B dot A times A. We are given that A is a unit vector. And we're also given that vector D equals the difference between B and C. We are asked to prove that D dot A is equal to 0. So as you can see in here, we're trying to multiply this vector D here, this vector D here, with the vector A. Now they appear in 2 different equations. So the first idea that comes to mind is we have to bring them in the same equation so they mingle together so that we'll be able to somehow simplify the expression and arrive to this conclusion. So I'm going to start off from the given information, and I'm going to say that if I am given that vector D equals B minus C, and I want to bring D in here so that it mingles with a vector A, then what I would do is express either vector B in terms of D and C, so D can go in, or vector C in terms of B and D. So in both cases, I need to bring D in. So in this case, what I decided to do is let vector B, use vector B equals D plus C. And knowing now that C equals B dot A times A, then we're going to say that vector C then, which is B dot A times A, can be dot producted with A by multiplying both sides of the equation by a, and not just multiplying, but dot producting each side of the equation by a. So this will bring us to the following conclusion. Now remember that whenever you transform the equation of any function or any proof or any theorem, so reread the equation carefully and see what new meaning the new transformations have added to the equation. Now remember that, as we mentioned, this would be a scalar multiplied by a vector, dotting with a vector. So this is just a number in here, which means that when you have a number, let's say Ka, and you dot it with another number, then you can dot these two together. So therefore, we're going to say that we have here a scalar multiplied by a dot a. So these two will go together. And on the left side, we still have c dot a, so nothing has changed. So in the next step then, we're going to say that c dot a, so still working on what we had in here, would be b dot a multiplied by a dot a. So it's a scalar. We're going to write as it was before. So we just write this step to explain in here why we were able to combine a dot a together. So the next thing we want to do is take care of a dot a. Now, a dot a is very easy to take care of because we know a dot a is a unit vector, and that's the whole reason why we multiplied by a in here, so that we would actually kind of get rid of this a that is in the side of the equation, so that we can have a free pathway to get to vector b in here. So a dot a, according to the dot product formula, would be a times a magnitudes cosine of 0, because the angle made between a vector and itself equals 0. So cosine of 0 is equal to 1. So that's a unit vector, obviously. Then the magnitude of the unit vector is equal to 1. So remember, that's multiplied by 1. So 1 times 1 times 1. So which tells us that this entire thing in here would be equal to 1. So now when we write this equation, c dot a equals b dot a times 1. So remember always where we are trying to get to. So we are trying to get to d dot a, and what we have right now in the equation is c dot a equals b dot a. So we don't have d and a working together. Now, it's time for d to make an entrance to this equation. So we will replace the vector b by vector d plus c. And let's see what happens. And whenever we make transformations, so whenever we replace a term in an equation, and with the purpose of, trying to bring it to the final statement that we want to prove, try to do this with curiosity and without the worry that, oh, is it going to work or not? Because as a matter of fact, whenever we make transformations, there is a sense of insecurity. So where this is this leading? There is some reasoning, obviously, that is going on in our head, because we're not just, doing things randomly with no purpose. But always it is associated with a little bit of insecurity, because we don't know if we are on the right path. But try to replace this sense of worry and insecurity with curiosity, because even though things don't work out the way they are supposed to, then in the process of discovering something that is wrong, we'll understand why it's wrong, and it will give us an idea of how to fix it. So, and that is learning, pure learning. So back to our problem in here, we have c dot a equals b dot a, and we want to bring d in. So d equals, we said, d will be coming in by replacing b. So b is d plus c. So we'll bring d plus c in. And now we'll have this vector b replaced by d plus c dot vector a. On the left side, we're not making any changes. So let's take a look at this side of the equation now. We have dot product the sum of two vectors with another vector. So this is a vector, this is a vector, they're dotting each other. Based on dot product properties, then we can multiply each vector inside the bracket by vector A in a dot product. So this would be D dot A plus C dot A. The left side of the equation remains unchanged. So you can probably see that we have arrived almost to the end of the solution. So this is the hero of our equation here. This is what we are trying to isolate, D dot A, which means that we're going to leave D dot A on the right side of the equation, and we'll bring C dot A to the other side. And obviously, the sum from positive will become a negative. So as you can see here, we have C dot A subtracting C dot A. So these are same terms. So which means that the left side of the equation will be 0, and D dot A be on the right side, which means that D dot A equals 0. So I hope this made sense, and I hope you found the instructions useful. And always, always learn with curiosity and learn with persistence and enthusiasm. Bye for now.